Hi everyone, welcome to Job Fever. So today we are going to learn new topic which is related to collections framework. So we are going to cover linked list today. In this series, we will cover all this topic, which is what is linked list. We are going to cover first, then linked list in hierarchy of collections. We are going to cover then how does linked list work internally. We will see then constructors in linked list. All the constructors we will see which is present in linked list, then key point of using linked list in Java. Okay, why we use linked list, so we'll see. And then advantages of using linked list, then disadvantages of using linked list we'll cover, then methods which is present in linked list, all method we will see, and difference between list and linked list. Okay, which is very important questions according to interview, difference between list and linked list. And at last we will see coding questions of linked list. So we'll add linked list, we'll do some operations, almost we'll see all the necessary methods in coding question. So we are going to cover all these questions in this series. Okay, so let's get started. So we are going to see what is linked list. So linked list is a part of Java collections. This is linked list is a part of Java collections framework and implements both list and DQ interfaces. Okay, so it implements list and DQ interfaces, allowing it to function as a doubly linked list. Internally, it uses doubly linked list concept to perform linked list operations. Okay, it differs from linked list in how it stores elements, offering more efficient insertion and deletion, but slower access when using indexes. So it is more efficient in deletion and insertion because order time complexity will be very less than array list. So if you are doing any insertion and deletion, to better to use linked list rather than array list. So time complexity will be order of 1 in case of linked list for deletion and insertion. So second, linked list is a part of collection framework present in java.util package. So this class linked list will be present in the java.util package. Okay, and this class is an implementation of linked list data structure. So this class is internal. This class is internally linked list data structure. Okay, it use w linked list just now we seen here, which is linear data structure. So linked list data structure is a linear data structure where the elements are not stored in contiguous location, and every element is separate object with a data part and address part. The elements are linked using pointer and addresses. Each element is known as a node. So I will try to describe shortly. It will not more time to understand doubly linked list. So linked list internally use doubly linked list concept. So how it works I will tell you. Give me 1 minute. Okay, so it store data as a node. Okay, so let's imagine we have linked list. Okay, so we are going to store four four element. Okay, in linked list. So how it will store, so it will store as, okay, we are going to store four linked list. Okay, so so our linked list will be visible like this. Okay, at the time of storing, so we are going to store 10 here. Okay, then we are going to store 20 here. Okay, and then we will store 30. So we are going to use here doubly linked list. Okay, so here 30 will be there, data will be available here 30. Okay, so what is happening here, so in doubly linked list, the first, here it will store the address of previous node, and here it will store the address of next node. Okay, this is one node. Okay, so let's imagine the address of first node will be xx10. Okay, and address of second node will be xx20. Okay, so xx10. Okay, so this is the address of first node, and address of second node will be xx20. Okay, So this 20 will be stored at address xx20, xx20, and 30 will be stored at address xx30. Okay, let's imagine, and then we'll try to understand how w linked list work internally. Okay, it will not take more time to understand because this is the basic concept. If you not understand, it will it might take time to understand. So this is the basic. So here there is no previous node in case of w linked list. So here what will be the value of previous? It will be null. Okay, so there is no any previous node because this is the first element 10. So here it null will be stored, and this is the this here it will store the address of next node, which is xx20. So it will store here xx20. Okay, xx and 20. And in second node what will happen here? So data which is available at second node, okay, is 20. So here it will store the address of previous node, which is xx10. So it will store here xx10, xx, and then 1, then 0. Okay, so and here it will store address of next node, which is 30. Okay, the data we have stored here, which is 30, but address of this node is xx40. So here it will store xx40, xx and 40. So this is the address of second node, address of the next node. So here it will store address of next node, and here address of previous node, address of next node, and then address of previous node. So here only we are going to store three objects, okay, three data. So we are not going to take fourth one. Say at the time of third, what it will do? So here it will store again address of first previous node, which is xx20. So the xx20 will be stored here. Xx20 is the address of previous node, xx20. Okay, but what will be what we can store here? Okay, because there is no next node. Okay, there is no next node. So this is our last node. So here it will be again stored null. Okay, because there is no next node after this node. So null will be stored here. So xx10, xx20, and xx30. Okay, we have stored 10, 20, 30. Okay, so here data will be stored, which is 10, 20, and 30. Okay, and here at the first previous node address will be stored, and here next node address will be stored. Okay, so like this w linked list work. Okay, so linked list internally use w linked list to store all the data. Okay, all the objects. I hope you understood this basic concept of linked list. So we are going to move forward to understand new topic, which is hierarchy of collection. So we are going to see how linked list work in collections framework. Okay, so this is the complete picture of collections framework. So this is a root interface which is iterable, and then collection interface. So collection interface implements collection is also interface. So collection interface extend iterable interface. Okay, and then list is interface. So list interface also extend collection, queue also extend collection interface, and set also extend collection interface. So but and list, these all are the implementation of list. Okay, array list, linked list, vector, and stack. But we are going to concentrate on array list. No array list, we are going to concentrate on linked list. Okay, so this is the linked list. So the linked list is a direct implementation of list interface. So linked list implements list interface. Okay, and there is second things, which is dq. So dq is a class. So sorry, dq is a interface. Okay, which extend q list. Okay, so q is also a list and dq is also a list. So dq extend q list. Okay, and linked list extend dq. So so we can say linked list class implements a list interface and implements dq interface. Okay, so both the so we'll get both the method. We will get the both the methods in linked list. So some of the method will be from list interface. Okay, and some of the method from dq interface. So it's act like both, like dq and list. Okay, so it's a mixture of list and dq. So we are going to understood linked list. So I shown you the complete picture of the collection. uh, so it will be easy to understand. We are going to cover next topic, which is how does linked list internally works. Okay, so since a linked list act as a dynamic array and we do not have a specify the size while creating it, the size of list automatically increases when we dynamically add and remove item. So there is no any size. So once it will be once the size will be completed, okay, full, then it will be increased dynamically. The linked list is implemented using a double linked list data structure. So just now we seen, okay, in previous slide. So the main difference between the normal linked list and double linked list is that a double linked list contains an extra pointer. Okay, so just now we seen there is two type of linked list, which is first will be the single linked list and second will be the double linked list. So in single linked list it will only one address will be there. Okay, so that address pointer will store the next address of your next node. Okay, but in case of a double linked list, just uh, just now we seen the double linked list. So it has two place to store the address pointer. Okay, so in first it will store the address of previous node, and second it will store the address of next node. So this is the difference between the single linked list and double linked list. Single linked list and double linked list. Constructors in array list. Okay, so how can we create the linked list, sorry, constructors in linked list. So how can we create the object of linked list? So we can create with the help of the constructors. So we can create like this. Any, no need to pass any parameter here. Okay, this constructor is used to create an empty linked list. If you wish to create an empty linked list with name ll, then it can be created at. So this will be the reference variable name ll. Okay, linked list. So like this we can create. And there is another option by we can pass the collection inside the as a parameter in linked list constructor. Like this new linked list that I'm creating. This is the this collection may array list. Okay, or any other collection you can pass here. So both the way we can create linked list object. And key point of using linked list in Java. So why we use linked list in Java? So linked list is implemented as a double linked list. Each element, that means node, contains a reference to the previous and next element in the list. Okay, so just now I shown you in previous slide I shown you. So in linked list, in double linked list, we can store address of reference of the previous node and reference of the next element. Okay, and allowing for bidirectional traversal. So uh, so this is the advantage of linked list. So it will be better to use linked list, and time complexity will be very less because it's pointing to both direction, previous and next. Efficient insertion and deletion, unlike linked list. Efficient for insertion and unlike array list and linked list is more efficient for inserting and removing elements in middle at both end. Okay, order of one for these operations, as no element need to be shifted. However, random access getting elements by index is slower order of n compared to array list. So if you want to insert or delete from middle of collection, so it will be better to use linked list. Okay, because time complexity will be order of one. Okay, so if you want to remove, so what you have to do, I will see quickly. I think in previous slide we have covered this. Okay, so if you want to remove this 20, so it will not take more time to remove. Why it will not take more time to? So because in next here, okay, at the first node, what we can do in next, okay, in next address we can pass xx40. Okay, instead of passing xx20 we can pass xx40 here. Okay, so it will not take more time. Okay, so time complexity will be order of 1 in case of insertion or deletion. Okay, so this is the advantage of linked list. Okay, so time complexity will be order of 1 for insertion or deletion in middle of your linked list. So let's go again to our topic. And next, efficient insertion deletion, just now we seen. Okay, implements list and dequeue. So linked list implements both the interface, which is list and dequeue interface. As a list, linked list can store element in sequence and allow positive positional access, and as a dequeue in support operation at both the beginning and the end of the list, functioning like a dequeue, functioning like a queue or a stack. Okay, so it works like list and dequeue null element. So linked list allows storing null element. So we can store null element in linked list, same as array list. So it is also non-synchronized. Okay, this is similar to array list functionality. This is linked list is not synchronized, meaning it is not thread safe. External synchronization is required when used in concurrent environment. Okay, because it is not synchronized, so it is not thread safe in multi-threaded environment. An advantage of using linked list, so dynamic size, as with vector the size of linked list can grow or shrink dynamically, so we don't have to worry about setting an initial size, so it will grow dynamically. Okay, like vector. Efficient insertion and deletion, just now we seen, this is advantage of insertion and deletion. If you want to insert or delete from middle of your collection, then it will be better to use linked list. So flexible iteration, with a linked list you can efficiently iterate through the list in each direction, since each elements has reference to both it. Okay, actually it is easy to iterate also because it is pointing, it points both the direction, that is left and right, previous node and next node. Disadvantage of using linked list, performance wise, so linked list has a slower performance than array list when it comes to accessing individual elements. Okay, this is because you need to transverse the list to reach the desired element, whereas with array list you can simply access the desired element using an index. Memory overhead, linked list requires more memory than array list because each element requires additional memory for the links to its predecessor and successor. Now we are going to see all the method which is available in linked list. Okay, some of linked list implement list interface. Okay, linked list implements list interface. So some of the method will be from list interface. Okay, and some of the method will be from interface. So I will show you the code of the linked list so that it will be easy to understand. So which method is from queue and which method is from list. So this is a link list. Okay, I'm going to show you internal of linked list. So this is a linked list class. So linked list extend abstract sequential list and implements list and dequeue. Okay, so if you see the list, So some of the methods are present in list, which is size, is empty, okay, contains, iterator, to array, add all, okay, remove all, sort, equals, hash code, okay, add, remove, okay, index of object, last index of, okay, list, iterate, sublist, splittator. Okay, all this method we have already covered in array list video series. Okay, so you can also go and you can also check that playlist. So these are the methods available in list. Okay, and if you check the DQ, so DQ extend queue interface. So some of the method are from DQ. Okay, like offer first, offer last, remove first, remove last, poll first, poll last, get first, get last, pick first, pick last, remove last occurrence, okay, add, offer, remove, poll. These all are methods from queue. Okay, push, pop, queue interface. Okay, if you see, and queue extend, DQ extend queue interface. So some of the method will also from queue, like remove, poll, element, pick. Okay, so these are methods from queue. These methods belongs to queue interface. So this is the internal of linked list. So linked list extends abstract sequential list. Some of the methods are from abstract sequential list, like get, set. Okay, these are the method, remove by index, add all, iterator, list iterator. Okay, so these are the methods which is present in abstract sequential list class. Okay, which is extended by linked list. So we seen all the class and interface which is available inside linked list. Okay, so we are going to see method, and we'll try to understand the purpose of this method. Okay, add, we use it to add the element. Okay, so the method insert the specified element at the specified position in this list. So add is there, and add by, you can here add object, add all by index. Here we have to add the index and the collection. Okay, and add all, so we can add the collections. Add first, so element will be stored at first place. At last, the element will be stored at last. Clear, it will clear all the array list, sorry, a linked list. It will be removed. And clone, you will get the one copy of linked list. And contains, if contains, then it you will get true and false. And descending iterator, this method returns an iterator over the element in this DQ in reverse sequential order. An element, this method is retrieve but does not remove, okay, the head of this list. So it will fetch the first element, but it will not remove. Get by index we can fetch. Okay, and get first, you will get the first element, and get last, you will get the last element. And index of, so you will get the index of your object. If it is not present, you will get the -1 last index. Okay, so last index of your object. And list iterator, this method returns a list iterator of the element in this list, starting at the specified position in this list. And offer, so this method adds the specified element as the tail. Okay, last element it will add. Offer first, so it will add at the front of the list. Offer last, that means that it will add at the last of the list. So we have offer, first, and last. So first will add at the first, and last will be at the last. And pick, so this method retrieve but does not remove. So first element it will retrieve, but it will not remove. and pick first. This method retrieve but does not remove and the first element of this list or return null if there is no any value. If and pick last, so it will return the last. If a value is not there, then it will return null. And poll, this method retrieve and remove the removes the head first element of this list. So it will remove the first element and also return. This method retrieve and removes the head, which is first element of this list. And poll first, this method receive and removes the first element of this list or returns null if this list is empty in case of poll first. So these all methods are from DQ. Okay, DQ interface. Poll last is also there. Okay, pop and push. You know, this is okay. So this method pop an element from the stack represented by this list. Okay, so it one uh, pop, that means the it will delete, and push, that means the it will push, it will add, remove. So it will remove. Okay, so this method retrieve the and remove the head first element of the list, remove by index. So you can index wise you can remove by object, you can object wise you can remove first, it will remove the first element and remove first occurrence. So this method removes the first occurrence of the specified elements in this list. Okay, when traversing the list from head to tail. Okay, remove last, so it will remove the last of the element. Okay, remove last occurrence. So this method removes the last occurrence of the specified elements in this list. So it will be stored remove the last element and set. So here you can set the set the index wise, you can set object. Okay, at the index. So this method replaces the element at the specified position in this list of the specified element. So it will replace. Okay, set, that means it will replace. And size, so to get the size of linked list and splitter, this method create a late binding and fail fast splitter over the element in this list. So to array, this method returns an array containing all the elements in this list in proper sequences. So I try to explain all these method between 2 to 3 minutes. Okay, and you'll see the coding questions of all the method, all the important coding method, all the coding questions of all the important method. Okay, and you can play with all the methods so that it will be easy to analyze, it will be easy to understand. So now we are going to cover array list and linked list. So we are going to cover difference between array list and linked list. So it is it is very important question according to interview. So implementation wise we'll see. So array list implement resizable array. Okay, you can say growable array, resizable array, and linked list implementation of linked list is doubly linked list. Okay, package, both are available in same package. Memory allocation stores elements in a dynamic array where contiguous memory is used, and store elements as node where each node holds a reference to the previous and next node. Access time, order of one for fast random access and slow random access, order of n. Okay, insertion time. Okay, at end if you want to insert with the help of array list, so it will take order of one. Okay, and for insertion list, if you want to insert at end, then same order of one will be for in linked list. So in at the time of insertion at last, so order of time complexity will be same for both scenarios for at least and linked list. Insertion time in middle, if you want to insert something in middle, so linked list is faster because time complexity will be order of one in case of linked list, and in case of array list if you want to insert something in middle, so order of time time complexity will be order of 1, because if you are going to insert all the index, you have to shift. So this is the issue in array list. So better to use linked list if you are doing anything, that means insertion and deletion in middle. So deletion at end. So deleting anything from end. So you can use anything like linked list and array list. You can use both. Okay, because in both the scenario, time complexity will be order of 1. Deletion at middle. So it is faster in case of linked list. Okay, if you are deleting anything in middle, so it will be slower in case of array list, because array list internally use dynamic array concept. Okay, so if you are deleting anything, then again you have to shift your all the elements, you have to shift iteration time, faster iteration due to contiguous memory access. Okay, and slightly slower due to pointer hopping between nodes. Memory overhead. Less overload stores only data in an array. Okay. And more overhead due to storing pointer along with data. Use case for adding, removing. Best for frequent retrieval and infrequent insertion removal, especially at the end. So best for frequent retrieval if you want to retrieve. Okay. So in that scenario, you can use array list. And best of infrequent insertion removal at the both beginning and middle. Okay, so in case of beginning and middle, if you want to insert and delete, then in that scenario you can use linked list. Initial capacity will be 10 for the array list, and there is no fixed size for initial. There is no fixed size for linked list, and for array list there is fixed size. So default size will be 10, and the size behavior automatically size by creating a new array and copying element costly for large list. Okay, no resizing required. Memory efficiency, generally more memory efficient, less memory efficient due to extra pointer. Okay, so here you have to memory wise it's not good, but performance wise very good. Linked list is very good if you are doing insertion and deletion. Okay, in between your collections. Indexing, okay, supports efficient indexing order of 1. Okay, inefficient indexing order of n. Thread safety, okay, so both are not thread safe. Okay, because all are not both are not non-synchronized. So in case of array list, we can store null value, and in linked list also we can store null value. Transversal method supports both iterator and list iterator, and supports both iterator and list iterator. Okay, so it supports list and iterator. List iterator, iterator and list iterator for the both the scenario. That means for both the collection, array list or linked list. So we have covered all the features of array list and linked list. Okay, some of the similar and some of the we have differentiated array list and linked list. So now we are going to see the coding questions of this array list. So I have covered the all start. So I have created one linked list. Okay, so linked linked list. Okay, equal to new linked list. So here I'm adding. Okay, list dot add list dot add. So apple will be added here. Okay, so we have another method which is add first. Okay, so mango will be at first position and then apple. Okay, and at last. So now we have apple, first we have mango, then apple, and then last will be orange. Okay, so our scenario will be mango, then apple, and then orange, and then add at first index. So what is there at first index? Okay, so that will be delegate to second index. Okay, and now for at first, what will be at first index? Banana will be at first index. So what will be our scenario? if you will check, okay, so at first what will be, mango will be there, and then banana will be there because we are adding at index first, okay, and then we have apple, and then we have at last we will be have orange. Okay, so this will be the output. Let's run and check are we getting correct output or not. See, we are getting mango, banana, then apple, then orange. Okay, let me run one by one because you will be confused. Okay, so we have added list dot add. Okay, let me run list dot add. So here we are getting apple. So now we are doing list dot add first. Okay, so mango will be at first position and apple will be at second position. So I'm running again. So now we are getting mango and apple because we are adding with the help of list dot add first. Add first is a method. So we are getting mango and apple, and at last after that we have list dot add last. Okay, that means the orange will be added at last. So let me run and check. Are we getting mango, apple, and then orange? Mango, apple, and orange we are getting. Okay, so now we are going to add banana at first position. First position, that means the here. So now at first position apple is available. Okay, so now apple will be at apple, banana will be available, and then apple will be available at next position, and after that orange will be available. So we are going to add banana at first position. So let me check output. Mango, banana, apple, and orange should be there. Mango, banana, apple, and orange. So we are getting the correct output. Okay, that means we are now. I'm going to access elements. Okay, so how can we access with the help of the get method? So we have get first, get last, and get. Okay, same like add first, add last, and add. Okay, we have get first, get last, and get. So get first will get the first element, get last we will get the last element, and second we are fetching a second element. So we are providing here index of second. Okay, so index of second, so here we are providing first. Okay, because for fetching we provide 0, and for fetching second we provide 1. So let me run and check. So we have to uncomment this, then it will, then we'll be able to see. Yeah, we are getting first mango. Okay, which is right. Second banana we are getting right, and last we are getting orange. Okay, which is right. And now we are going to remove. Okay, so we are going to use remove method and remove last. So with the remove method, remove the first element, and we remove last, remove the last element, and we'll print. Let me run and check are we able to remove correctly or not. So we have removed the with the remove method we have removed the first. So we have removed the mango. So now we are not getting mango. We are getting banana, apple, and remove last. So it's remove the orange. So we are not getting orange in this list. Okay, link list. We are getting banana and apple. So we are getting the correct output. Now we are going to search the element. So how can we search? So we can search with the help of these methods. Okay, so list contains, so it will return true if banana is available. List dot index of apple, so it will return index of apple which is first. Okay, and list last index of apple, it will return, so which is 1. Okay, apple is at one time. So let me run and we'll check the output. What is the output? Yeah, so banana contains banana, true. Okay, list contains banana, but we have list banana, we have in list we have banana and apple. So contains banana, has banana, So list dot contains a banana. Yes, so we are returning true. And first apple, okay, index of first apple. So we are getting 1. Okay, so apple is present as first position. First position is index first. So we are getting 1. Okay, so index of banana will be 0 and index of apple will be 1. So we are getting here 1. And last index of apple, we are getting last index of apple. What we are getting, because only one apple is there, so we are getting same for first and same for last. So now we are going to size. How can we check the size? With that size method we can get the size of linked list. So let me run this again. We'll get the size at last. So we have two fruits in linked list, so we are getting size of list is 2. Okay, so at last we have poll method. So what we can do with the help of poll, so retrieve and remove the first element with the help of the poll. Okay, so let me uncomment. So retrieve and remove the first. So we are going to use list dot poll. So first, in first one we will get, what we will get in first one, first banana is there. So in first we'll get the banana, and list after removing the first element, which is banana, we'll get the list. So in list we should get only apple. So let me run and check. We are removing banana, we'll get only apple. So we have removed polled, that means we have removed banana, and after removing banana we are getting only apple. So we can remove with the polled method, can remove first one. And we have pick method. Okay, so with the help of the pick method, we retrieve but do not remove. Okay, so we'll fetch the value. Okay, but will not remove. Let me run and check. So I think we have only one. So it's able to fetch. Okay, apple. Let me add here. Okay, list dot add. We are going to add here. What we are going to add? Orange. Okay, then run. See what we are doing here. So we have apple. Okay, we have added orange, so now we have apple and orange both. Okay, so we are doing list dot pick. So we are able to pick first, which is apple. Okay, but we are it's not deleting the element, we are only able to fetch the element. So we are able to get apple, but okay, let me run here. Let me print all the list after adding. Okay, so that we'll get both. We have added new element, which is orange. So now we are getting here list after pool. No need to list after pool. No, normally print. Or I will confuse. List after added orange. Okay. So we are getting list after added list after adding orange. We are getting apple and orange. Okay. So when we are doing list dot pick, so we are able to fetch first element of this list. So we are getting apple. Okay, and we are getting all the fruits name in list. Okay, because it is not deleting, so it will pick will only fetch, it will not delete first element. So now we're going to clear all the element which is available in linked list. So now we have two element in list. Okay, so after clearing you should get empty. Let me run and check. Yeah, we are getting the empty linked list. Okay, so we are getting the correct output. Let me comment, and now we'll do remove. Okay, because nothing will be there. If nothing will be there in list and we'll try to remove, we'll get the exception. Okay, so now we are trying to remove. This is list dot remove first and list dot remove last. Okay, so with the help of this we can remove. Let me uncomment it. And if you use remove, then first element will be removed. Okay, what is happening? Remove last first and remove last, then what should we get? We should get null, because nothing will be available in list. So let me uncomment this. Okay, so that we'll get. Let me done again. Yeah, we are getting dequeue after removal. Okay, so this is the method from dequeue. So we are printing dequeue after removal. So we are able to remove with the help of the list dot remove first and remove dot last. So I yeah. So if you are loving my effort, please like, share.